Okay, so I think okay. No, they put the names. So actually, the slides, the work was done by Sanghoon Cho, who was a PhD student of Pelin and Mark. Now he is a professor at Texas Christian University in Dallas, Fort Worth, some kind of like Dallas, Fort Worth area. yeah, Fort Worth. And his wife, Danhyang Lee, who is a professor at University of Alabama. Since they are getting married or enjoying their kind of, vacation with their family in their native South Korea, I was asked to present it. So they're like in the different, like 12 in the time zone, 12 hours away, and couldn't even join us. I'll just present the main points because I'm afraid I won't be able to explain in details the statistical technique that they put together. But I can talk about motivation and the whole kind of idea behind it. So the idea is that in reality, kind of like, I mean, when we want to estimate, for example, M&L model, we want to know the entire consideration set. Ideally, we want to know actually the no purchase options as well, like who didn't buy anything. But in the real world, things are not that good. And forget about the no purchase option. It's like usually can be only estimated as a kind of latent variable. But even consideration set is not usually known. So from the data that we've seen, either for initial offer or for the upsell offer, we don't know what prices, like kind of in most cases, we don't know what prices were offered to the customer. We know only what was accepted by the customer. So, but we know, like we can do some guesses because we know like what was offered to similar customers, and we know how other customers reacted to this like offers, their offers. So like imagine that you have multiple customers and each customer chooses something at certain price. So we know only what they chose and at what price they chose because it's like financial transaction. But we don't know what they were shown, but we can kind of make some assumptions and get some idea. So then we can work. So this is pretty much the picture that describes what I just mentioned. That you have a customer that of certain type, and this is like let's say single traveler, backpacker, and he is given the choice of 3 rooms at certain price, and he chooses some kind of like some specific room, and obviously they look at the attributes of the rooms that we know, and they choose a certain room. So this is a more specific example. We have certain booking dates. We know the length of stay. Difference, it means the booking window. And we know what room it was that they that was chosen. So these are different customers obviously, and they choose different rooms at different prices. So we don't know what was, for example, offered like kind of superior king room, water view, at what price it was offered to the first customer because he chose or she chose deluxe king room city view. So going into the data, we have a kind of choice variable, and we have a vector of k product prices. So a discrete choice MNL gives this well-known probability of the choice. And then we know some prices, and we assume that price for the choice is somehow distributed depending on the attributes of the room. So those prices are not fully observed, and so they are not kind of like part of the observed data. And like this is the example where this price is some function of attributes xi. X is the vector that are correlated, and then we have the probability for the choice y. I is given by the MNL, and alpha 1, alpha is the vector, and gamma is the price coefficient that is also assumed to be minus 0.2. So if we look at the full prices, like without missing, we have certain parameters. For the observed prices, we have like completely different data in terms of like median and mean and other distribution parameters that will be obviously very much skewed. So you can see that we can use like kind of the bias will be significant, and like if we use popular, okay, so let's start differently. So one of the popular imputation techniques is MICE, which is multiple chained equations. I think, and this is like multiple regressions on the averaged parameters, I think. So, and KNN is K nearest neighbors technique that kind of like averages the parameters based on the nearest parameters. Kind of. So if we use mice for this example, then we have significant bias, and we obviously want to improve this technique. So in order, like the basic idea of this is that we know not only the price, the kind of the data, this kind of matrix with missing data, but we know the outcomes, and we can estimate both simultaneously the model and missing parameters. So this is kind of how this technique is developed. So we have random parameters, and we have prices that are not fully observed. So again, we have this MNL model, and we have some price vectors that are not observed, and we assume this distribution based on the choice probabilities. So this is this distribution for the unknown, for the unobserved prices. So we assume that there are certain distribution parameters, and we want to estimate those parameters based on the model. So we have these observations based on the demand model, and in addition to the model parameters, we have parameters that were of the price distribution that we want to estimate as well. So we go through this pretty much standard parameter, standard parameter estimation. We have the likelihood function based on the observed data, and we use EM expectation maximization algorithm to solve this problem. So so this is the example for the normal distribution of the prices based on the parameters. So we use the imputation step, weighting step, and maximization step to estimate those parameters. And we can say that in our method, based on the proposed and the existing method, we have like better estimation of the parameters, and this is the comparison on the bottom of the slide. There is a comparison between the results of the proposed method and the mice technique. And this is some, I think, simulation results. Also, we can see that we reduce the bias significantly, and of course, like we have like the model choice is a significant factor here, and we use like single parametric model as multivariate normal distribution, and like there are some ideas how to do it. So the second method actually uses the mixture of these models, and this uses like assumes like there are some clusters that there are some clusters of the customers, and we have soft clustering. Each customer belongs to the mixture of the clusters with certain probability. And this is a kind of approach that Sanghoon used in his paper, and that we also use, like kind of assuming that we know the full consideration set, and we like actually Sanghoon and Danhyang, they kind of use this technique now to impute the prices. So I'll skip this because I'm not quite sure I can say it. So I'll jump straight to the conclusions, and I want to say that this study actually proposes how to incorporate imputation into the model estimation, and we're going to do more experiments, and when they come back to the States, we'll have kind of more discussion of the data. But initial results are very encouraging, and sorry, so initial results are very encouraging, and we're going to keep working in this direction. Okay, so I think that concludes my talk. So if you have questions, please ask. All right. So thanks a lot to Sanghoon and that. So I think it concludes our workshop. So thank you very much for attending and presenting.
Thank you for organizing.
Yeah, thank you.
Thank you.